Here we've got the integral x³ e to the x dx, and because we're dealing with a product here, it looks to be an integration by parts problem, and if I were to guess, this x³ indicates that we're likely to deal with a repeated integration by parts problem. So we'll start by letting u equal x³, du will become 3x², we'll let dv equal e to the x, and we'll integrate that to get v equals e to the x. With integration by parts, we'll go across the top and then down over. So we'll start off with x³ e to the x minus the integral. We have a 3 here we can kick out front, x² e to the x dx. And this is what I mean by we'll be dealing with a repeated. You'll notice that we started with a 3 here, and now we've got a 2. My best guess is that down here we'll end up with just a regular x. So moving along, we'll have u equaling x² once more. The derivative of u is 2x. dv looks to be e to the x again, and we'll integrate that for v to get e to the x one final time. And then we'll go across and down over for integration by parts again. We've got x³ e to the x minus 3 times. This is where we go across. x² e to the x minus now the integral with a 2 out front, 2x e to the x dx. And this is where we have that single x. We went from 3 to 2 to 1. And we've got one last integration by parts pair, so we can let u equal x. The derivative of u equals the derivative of x. dv equals e to the x again, and we can integrate to v to get e to the x once more. We'll go across the top and down over again. We've got x³ e to the x minus 3 times x² e to the x minus 2 times now x over to e to the x, so x e to the x minus the integral of e to the x dx. The integral of e to the x is just e to the x. So now we've got x³ e to the x minus 3 times x² e to the x minus, we can go ahead and do this distribution now, negative 2 times x e to the x is just negative 2x e to the x. And then we have a negative e to the x here times a negative 2 is a positive 2e to the x. Because this integration here doesn't have any limits, we must add a constant at the end. This is an indefinite integral, after all. We'll close that bracket there and distribute the 3 across. So our final answer is x³ e to the x minus 3x² e to the x plus 6x e to the x minus 6e to the x plus c. And if we wanted to, we could extract these e to the x's, and that would look like this. It would be e to the x times x³ minus 3x² plus 6x minus 6 plus c. Whichever way you'd like to write it, whether it's the top version or the bottom version, both are equal and both are just as accurate as a solution for our original integral, x³ e to the x. If you have any questions, or if you'd like me to go through any other particular calculus or physics question, let me know in the comments below. Otherwise, I hope you found this helpful.